Good afternoon. My name's Paul Bonner. I'm the Technical Director at Kubus. I'm going to take a few minutes of your time just to introduce you to Kubus, who we are, where we've come from, the type of things that we do for our customers. I'm then going to hand you over to Rob Freeman from Juniper, who'll talk to you about AI in the data center. Who are Kubus? We were formed back in 2003 as hardware.com. And I see a few people nod around the audience. You might remember us from back then. We were a supplier of used and refurbished Cisco. We used to buy on a global basis, second user, excess inventory, bring it into our location in Swindon. We used to refurbish it. We used to even spray the stuff. I remember the cans of Cisco grey paint. To get that crackle finish on that paint took us a lot of years, but we got there in the end. Then we used to package it up and then supply it with everything you got when it was brand new. So the accessories, the cables, and everything, and then we sold it on to customers. We actually became the largest supplier of refurbished Cisco in Europe. At any given time, we had about $15 million worth of stock in our warehouse. So it was a massive business for us. In 2013, we partnered with Juniper Networks. We became an elite partner very, very quickly. We rose through Elite Plus, and finally in 2023, we became Elite Plus with Partner Assurance, which is the highest level of Juniper partner that you can get, which not only shows our commitment to Juniper, but also their trust in us as an organization that we can deliver Juniper products and services into our customer base. We're also a Juniper PSS partner. So for those that don't know what that is, we can provide authorized Juniper support with our engineers giving you level 1 and level 2, with Juniper providing RMA spares to site, level 3, and also engineer to site. We've got about 20 to 30,000 assets under support at the moment. We've built a very strong technical team at Kubus. So we've got engineers covering the complete range of or portfolio of Juniper, from JNCIA all the way through to JNCIE. We've got Cisco accreditations, Fortinet, Palo Alto, and other leading networking vendors. So we have built up that strong technical team that's responsible for pre-sales, post-sales, consultancy into our customer base. We also have a pre-staging department, or technical operations, and their role is to pre-configure equipment before it goes out to site. We work a lot in the service provider community with CPE deployments. Currently, one of our customers, we service about 1,500 devices a month, where they provide configuration via their Jira ticketing system. We then download the configurations, add them to the devices, change the software, test them, upload test logs to the Jira platform, and then ship them to a location where they're actually installed either by our own engineering team or those of the end user or the customer. We believe in building long-standing relationships with our customers. We're not a box shifter. We want to work closely with our customers. I work very closely with one particular company. There's no one here from them today, but I've been working with them since about 2010. They're a global provider with DC locations across the globe. At their peak, they had 28 DC locations with Kubus, or hardware.com at the time, providing the equipment for all of those locations. Me and my team actually installed ourselves around 17 of those locations. So we work very closely with that customer in particular. We've just completed a DC consolidation project with them, where they've not only changed providers to a different DC provider, we've also consolidated those sites down. So we've done a lot of implementations of new environments. We've also removed assets from one location to the other. The most challenging of which, we did a move in the US, where we shut a DC down on a Friday evening, about 8 or 9 o'clock. We loaded 200 assets into a truck, and it was taken 800 miles across the US, where the only time the truck stopped was for fuel and to change drivers. We then took all those assets out and then built the data center at the new location, got them all up and running by the close of the maintenance window on the Sunday evening. So that customer in particular, we then go back into their DC locations and provide a service where we take all the old assets that are left out, we send the ones that aren't going to be used for anything else for disposable, and then we can do a cage sweep so they can hand that location back to their provider of the DC. If you want to know anything more about Kubus, we have got a booth downstairs. We're the booth without the banners, just to let everybody know. We're the one in the corner. blame our marketing department. But we are downstairs. We're happy to talk to you about what we do for customers and how we can help you. And then we can basically help in sort of pretty much any area that you're interested in. I'd like to hand you over to Rob Freeman now. Thank you very much for your time, and there is some time for questions at the end. Thank you.
Thank you. Hi everyone. Blimey, it is bright up here, isn't it? So Rob Freeman from Juniper Networks. So my role in Juniper is I head up our global business for what we call the AI data center. And I know I'm going to say AI and half the audience are going to go, ooh, no, we're going to have some AI washing nonsense, okay? Don't forget, everything with AI, machine learning, I'm wrapping it all under that single term. And ultimately, it all runs in a data center somewhere, and it is absolutely electric at the moment. The amount of activity and building, it's a really exciting time for networks and data centers in particular. So I'll drill down a bit into what we're doing in that space. But I also need to start out with the word of solidarity for my Arista colleagues. I know that horrible feeling of when you get the call from a customer, everything's on fire, and it's your fault. Yeah? So we know we all have bugs, and it's how you approach it and work together. And I know nobody takes it more seriously than Arista, same as we do at Juniper and all the other vendors. But yeah, we do feel it when it happens. So thank you. So, right. So I'm going to talk a bit about these data centers that are being built for AI. I know there's a presentation later coming as well, talking more about the mechanics of the data center. I'll talk about it from a networking perspective. So I don't think we've had this much excitement in the data center market for a very, very long time. Yeah, we all see the buzz about it, and even if you strip off the stuff that is marketing fluff and nonsense, the reality is we're seeing growth like we've never seen before. And it's about this transition that we're getting because of AI. Again, I apologize for using the term, but it's a changing paradigm around processing, computational ability, and it is a real shift, and that has a massive knock-on for data centers and especially for networks. You know, we've seen it through some of these transitions in the past. I remember back to just about that first one when the web was starting to get going, and that's actually when Juniper started up 29 years ago, and of course ceased to exist as an independent company last week. So any questions about HPE, you can obviously come up to me later and I can talk about what we can, but we're very excited about where that's going to take us. And we've gone through these iterations, and in all of them, networking's had a very, very big role to play in supporting that transition and getting the most value out of the technology. But when it comes to the AI space, really networking, I would argue, and especially for this audience, is something where we've got a real contribution to make. You know, everybody focuses on the GPUs, the processors, you know, we all talk about NVIDIA, but if the network is not right, none of this stuff is going to work. So what we're seeing is we're seeing new innovations in networking. Obviously, Ethernet has gone up to 800 gig recently, well, about a year and a half ago. We've got 1.6 terabits in the lab. We'll have that out at some point in the not too distant future. And we're working along with Arista and others on Ultra Ethernet to bring some amazing new capabilities there. But it really is a wonderful time to be in networking. So what do I actually mean by AI and the infrastructure that's underpinning that? Yeah. We all think of things like, you know, Elon Musk's big Colossus out in Memphis, you know, that crazy huge place with all the gas turbines. But actually, it's more than just about big data centers. So, and as typical with all technologies, customers will end up deploying a hybrid approach because one size does not fit all. So there will be some huge data centers out there that are training those foundational models. But lots of these new providers are springing up. We call them GPU as a service or Neo Cloud, or there's some other awful terms out there for them. But customers will use a bit of everything, ultimately, and it all needs to be stitched together. We've then got, obviously, there's no point training a model. That doesn't really do anything. That's where inference comes in. So this is where you're asking questions of the model, be it, you know, when you're talking to ChatGPT on your phone or more sophisticated use cases. That's going to be way more distributed. That's got to be closer to the users where latency matters. We've got topics like data sovereignty is huge at the moment. Ever since the US election, I think Europe has woken up to the fact what the Cloud Act really means, and organizations now know they not to make sure their data resides in a country under the jurisdiction of a government they trust, but also that the model that data is being used within also matters. So all these things are really driving this development, yeah? And all of this stuff needs to be stitched together with incredibly high performance networking, low latency. The data center interconnect, when you're talking about moving these data sets around, is incredibly important. So I think for everybody here, this is going to be driving a lot of the work that we do over the coming years. Right, and I want to sort of set the, I mentioned before, there's a view that when you're talking about infrastructure for AI, you're talking about NVIDIA. Yeah, and undoubtedly they've done a great job and their technology is amazing. But there is a bigger world out there and a very, very fast evolving ecosystem of players in that space. Yeah, and for some customers, you know, if you're Meta, you can go and write a $10 billion check to Jensen and get, you know, 100,000 NVIDIA GPUs in a mega data center. That's great. But there are different use cases, different requirements, people have different preferences and different approaches. So when you look along that middle stripe of accelerators, we see AMD coming up very, very quickly, not just on the hardware, but on the whole software ecosystem. They've really stepped up and they're putting huge resources into it. Don't discount Intel under their new leadership. I think they're going to come back with a lot of strength later this year. And then you've got all these other providers you might not have heard of, but people who are building custom silicon for doing different AI tasks. Yeah, so it might be particularly for inferencing. For example, we work with Samba Nova. They can do in a 10 kilowatt rack for inferencing what NVIDIA take 120 kilowatts in a rack to do. That's a big deal, yeah? You've also got huge players in the storage space in AI. There's very, very specific requirements around storage, and you need to think about your data strategy. Yeah, these are big questions for these customers. And then, of course, it all incorporates into systems from Hewlett-Packard Enterprise and many other providers who are out there. But if you're going to take advantage of this ecosystem, there you go, that's my soul animation. What matters, I would argue, is that you need to have an open network. We all know here that the way that you get connectivity is by having open, standard-based connectivity. Because pretty much every single thing on there will work with standard-based Ethernet. The other technology we hear about is InfiniBand. Most of that slide won't connect with InfiniBand. Yeah? So when you're working in an industry where in 6 months' time there might be an amazing new processor that transforms your business, you need to be able to connect it. So stick with the open standards, and that's why we're all working together on Ultra Ethernet. Okay, and networking gets very, very interesting within these AI clusters. So not every cluster is 100,000, 200,000 GPUs, or, you know, Meta are training Llama on a 32,000 GPU cluster. But there's an awful lot of smaller clusters that are out there in the world. But they all share one thing in common, is that they have an awful lot of networking going on. So we still find in the classic data center, you know, a VM farm, whatever, you've got a general purpose 1U server, 2U server. It's probably got 2 25 gig ports on it, maybe 100 gig, some kind of out-of-band management. You go and get your GPU-based server, you've probably got 14 network connections coming out of the back of it with a total of about 4 terabits per server. Yeah, it's a whole different ball game. Okay, and that's just the bandwidth. I'm not talking about the actual technical and protocol requirements of an AI cluster, and it ain't stopping. Yeah, this is NVIDIA's roadmap. You know, within 2 years' time, we'll have not just doubled the speed of connectivity, but quadrupled it. Yeah. And that's another challenge. The innovation cycle in AI has just got completely compressed. We're not used to waiting 3 years for a new server, 5 years even. Yeah, it's every 12, 18 months. And each iteration completely transforms the economics of the use case. So people are literally just saying, well, actually, yes, I spent 100 million on that infrastructure last year, but if I spend 200 million on this new stuff, I'll make the money back in 6 months' time. Yeah, it really is that dynamic. So again, it comes down to the network being up to the job. So, and I would argue actually that if you're going to invest money and focus in terms of driving the performance and ultimately the utilization of your cluster, networking really is the best place that you can spend some money. Okay? The GPUs are great, but the GPUs need to be fed data. A GPU that isn't being fed data is sat there idle, wasting money. And the way you would do that, no matter whether you're training models, doing fine-tuning, inferencing, all the different life cycles through AI, the network is fundamental to delivering that value to the GPU. And so you'll hear different metrics being talked about. So job completion time is how long does it take to train the model. When you're talking about inference, it's all about things like time to first token. So when you type the question to ChatGPT, how quickly does that first word come back to you? And then how long does the operation take to complete? But what we're finding now is that these models are becoming more complicated. They're not just one monolithic thing. It's a stitch of many different models working together, these things called mixture of experts. So instead of a single model trying to answer every question, you might have 20 different models, each of which are good at a different thing, and then some kind of brokerage working between them. But it all comes back to the network and the ability to deliver that response as quickly as possible before the user, or probably another AI agent sat behind it, gets fed up and moves on. So I'll skip through some of this because it's, on the time. And, you know, so I say this humbly that if you get the network right, it will pay for itself 10 times over. Because you see some operations out there, they're spending $30,000 a pop on GPUs, they've got hundreds of them, and they're sat idle for 50% of the time. Burning power, taking up space, needing cooling. Yeah, these are all significant issues I think we'll hear about later. But if you get the networking right, then you actually maximize that return on investment. So, the kind of things that we're thinking about when we're building these environments, as you can see. So performance is just a given. Yeah, if you can't deliver 400 gig, 800 gig networking reliably with all of the right lossless Ethernet characteristics, all the right load balancing, congestion management, then just, forget it. That's the basic table stake. But then how do we approach this complexity? And it was sort of striking listening to the first presentation about the traditional challenges of running a data center are just multiplied tenfold when you're running something that is at that level of performance, that level of visibility. You need to be able to address issues before they've happened. Yeah, so this is where we actually start to use techniques around machine learning and AI to actually run the infrastructure as well. So spotting patterns in traffic so we can address issues before they happen. We can fine-tune things on the fly, because by the time somebody's reported a problem, it's gone. You're never going to find it again. Yeah, it's very, very difficult to do that. Security is becoming a more interesting discussion as well. It's not just about sticking some perimeter firewalls in there, blocking some ports like we used to do. Yeah, do you remember the early days of ChatGPT when you could say to it, how do I make a bomb? And it would tell you. Yeah, so security was implemented in the model. So then people would ask it, well, if I asked you how to make a bomb, what would you not be allowed to tell me? And it would tell you. So, and you can just imagine, particularly when engineers are involved, the level of complexity that gets into. So all of these different types of attacks to exfiltrate data out of models, particularly imagine you're a bank and you've trained it on your customer data set. Yeah, you've got to be so careful about that and think about these different threat vectors from all different points of the network. And I would argue, again, thinking about the open and proprietary topic is interesting, because you really don't want to go down a blind alley with the amounts of money that are being invested in this infrastructure. So, obviously I'm here from Juniper. I'll just spend a second just tell you what we're doing about it in this space and what we think. And so typically on these kind of slides, vendors like us and others will start off by showing you some switches. But actually, I think it's more important is how do you actually run the infrastructure? Yeah. So given the complexity in there, having the ability to have the right tooling where you can actually model the environment, design the environment, deploy it, and then run it is very, very, very important, probably more so than the actual hardware that underpins it. So much so that, in fact, our automation technology will run Cisco or Arista or indeed Juniper or indeed Dell if you're running Sonic. So taking a multi-vendor approach to do that. And to give you some example of the thing we can do is that we can actually design and fully configure an environment before it's been delivered. So by answering a few very simple questions about what the intention of the environment is, we will build a best practice configuration so you don't have to sit there at the command line, and it will then push it to the devices when they arrive. And then it will constantly monitor that environment to ensure it's delivering on the intention. Not about configuration, it's about, does this actually do what it's supposed to do? And I think back to some of the change control processes that were described in the first presentation. I'm not saying we could have avoided that one, but that's the kind of thing that we need to be doing when we're operating this infrastructure, is telling you beforehand that, hang on, that's going to do something weird, don't do that. Yeah. To give you one example of what we'll actually do, is that we will automatically tune all of the load balancing and the congestion management parameters based upon the workload that's running on the network at that time to make sure you get full throughput. Because otherwise trying to do it manually is just an impossibility. Hardware is obviously important, so this is where we're at today. So we've got 800 gigabits per second line rate on every port. Yeah, and you can get it in different flavors, whether you want shallow buffers or deep buffers, depending on the approach. We've got 1.6 terabits sitting in the lab that'll be coming out soon enough. Yeah. But then perhaps even more so, it's like we can't just throw our customers a box of bits and say, right, okay, off you go, you build this stuff, yeah? So we spend an awful lot of time testing, developing and documenting validated designs for doing this. So you can go onto the Juniper website, which has now got some HPE branding on it, but it's still juniper.net. And you can find reference architectures for particular different combinations of components in there. And this is a full blueprint for how you build this stuff. We do it with many vendors that we saw on that slide originally. And then we've got a lab in California where if you're interested in building this kind of stuff, you can actually come and try it out. Because most people haven't done this before. And if they're going to go and spend millions and millions of dollars, I'd rather they came and checked it worked first before they actually spent the money. Yeah. So we're doing quite well. You know, this was the Gartner report that came out a few days ago. This isn't the one that Cisco got bumped out of the leaders quadrant on. That was a different one. But this is in terms of building AI-specific infrastructure. You know, we've been placed very nicely on that one. And then for building general data center infrastructure, they stuck us at the top, which was very nice of them. So we can argue about Gartner all we want, but I think it's a good validation for where we're at on this stuff. So some of the customers that we're building these GPU clusters at, because we're not very good at shouting about this stuff at Juniper, but like, you know, we've got the very biggest clusters in the world. We're a part of that, and people like DigitalOcean, the world's biggest cloud provider, Vulture, who are the 32 regions around the world, the biggest privately owned GPU cloud provider, University of Wyoming. Surprisingly large installation. So lots of interesting different customers are doing that. So with that, I think that's everything, but I just say it's great, you know, and it's really driving interest and excitement in our industry, and I think it's going to be an interesting few years. Cool. Thank you.
Thank you very much. Does anybody have any questions for either Rob or
Yes.
Mr. Wilson?
Hello. Dave Wilson, Glide, but mostly here with my PC hat on. So it's, for a long time with Moore's Law and all the rest of it, there was like a running gag of if you've got a 2-year data crunching problem, wait a year, then buy a year later hardware and do it in 6 months.
Yes.
Like, how would you say the current tech landscape makes that more true or less true or irrelevant?
Yes, it's certainly a challenge when the timescales have been shortened to the point where often the lead time is longer than waiting for the next technology cycle.
The big NVIDIA slide you put up, you could genuinely believe, if I wait a few weeks and then buy the next one. Yeah.
And so a prime example of this would be, in fact, so NVIDIA have their big global tech conference, GTC, which is a GPU tech conference, last March, where they announced all the H100 and all that kind of stuff, massive fanfare. So they announced the Blackwell back then. This year, they basically came out and said the previous generation is dead. in 12 months, because the point is that the price per kilowatt, per token, per user justifies ripping and replacing hundreds of millions of dollars worth of equipment. So it is undoubtedly very difficult. The other challenge that you have is that not all elements of the technology are iterating at the same pace. So you might have GPU performance going like this, but memory bandwidth not going quite as quickly. And network performance has lagged a little bit until we got ourselves into gear a couple of years ago. So really it's a case of thinking about what is the use case, why am I building this, what is the actual business return that I'm expecting?
And can you make your money back in 1 year whilst it's still
Exactly. So can I get this stuff up, running and earning money quickly enough? So the ability to actually build and configure. I worked with a customer recently. They said it took them 2 weeks longer than expected to get the network working. That was all their margin for 12 months gone because they weren't earning money. Yeah. So it really is quite cutthroat. But the people building the big clusters, it's a little bit like an arms race. They're not really too worried about the income that's generated. It's more about making a presence, becoming established. And these big hyperscalers have got cash. They can do it, yeah? But when it comes to doing it as a business, you've got to be quite ruthless and think about what the use is.
Thanks very much.
Yeah.
And Greg.
Hello, Greg Choules, ISC. So if NVIDIA and the like are announcing one thing 1 year and saying, now rip it all out, put in the next new thing this year, they're presumably doing the same thing, repeatedly. What is the impact on the planet that we all live on?
That is a very, very good. That is a very, very good question. And obviously you've got the cost of the embedded carbon in the production of the equipment, plus the sheer amount of power that this stuff takes, not just to power but also to cool, because GPUs are probably the world's best converter of electricity into heat. Yeah, and this is something that has probably been lacking a bit in the industry over the past few years. So, we will try and do our bit in terms of what we can do. So the next iteration of switch that we produce, because of the new technology, particularly around the optics, will use about half of the power of the previous generation, even though it's double the speed. But there certainly has to be a lot more thought into the circularity of this stuff. So I think some of the interesting providers are the ones who are joining up longevity along with green power and heat reuse. And if we can actually get those things working, and that takes a lot of coordination from a governmental level to make sure we've got planning permission to get data centers in the right location, because it's all well and good putting a data center by a hydro scheme in Finland, but you can't reuse the heat because the closest habitation is 500 miles away.
Or you could use the heat to drive steam-powered turbines.
Yep, you can
produce more electricity.
You can produce more electricity, or you can do things like they're doing, like heating salt to store the energy. Or
if you store it, you've then still got to do something with it.
Exactly, but I think it should be incumbent on the people who are doing this to think about it a lot more.
But it won't be, will it? Because we want to do our thing and get ahead of the competition and make more money.
Well,
sorry.
Okay, do we have any further questions from the room? Take that as a no. I do have one question for you guys, though. Oh, there is one over here. Do you want to come over to the microphone stand? There's one over to the other side as well. Straight ahead.
yeah, that's it, we can hear you.
Could put them further back, it'd be easier. Hi, yeah, this feels really weird this close. I have to look up to you. Tim Chandler, so you mentioned Ultra Ethernet on one slide. I think that was published earlier this month, and it's 500 pages of stuff.
Yes.
What I did notice on a glance of 500 pages is it does seem to include layers all the way up to at least transport. Yep. You've got this UET, and it's replacing completely all the existing transport protocols.
Yes. So what?
So could you just say a little bit more about that? It seems a bit ambitious. Previous things you might run in a DC as an alternative to Ethernet don't go up the layers.
So part of the challenge that there's been in terms of making these protocols work properly is that the layers have not been coordinated. Yeah, so there's been no coordination between how load balancing is done with, for example, how transport is done, how retransmission is done. And so by actually defining all the layers together to achieve this, I think that's what's going to bring about.
But are these new layers and new protocols? Does the transport protocol of this in any way resemble any existing transport protocol like BBR or something?
Yeah. Yes, I think if you're familiar with Ethernet, this does look very, very familiar. Yeah, it's not too far out there, but the actual layer boundaries are much, much better defined. It's very clear what each layer does, and it's all working to the same goal. It's not kind of trying to tweak different things, and there was things spreading across layer boundaries, which was a mess. Yeah, but you're right. It's 500 pages, which is quite dense.
Well, I noticed there is already an Ultra Ethernet Lite being standardized, presumably because of that problem. But
Yeah.
otherwise, yes. For those who couldn't hear that, otherwise known as Ethernet.
Well, yes.
All right, thank you.
I still like fibre channel. That works, but that's fine.
Any more? No. I did have one question. Where you were saying before about how Juniper, with the NVIDIA turn up and say, sorry, that's all out of date, here's the next one. Do you find that with the network infrastructure that people are scaling up, or they're doing the same thing and throwing it away and buying boxes with bigger ports?
No, I'd say there's... So at the moment, most of our infrastructure that's been sold into this space is at 800 gig, whereas connectivity to these days is at 400 gig. So people are always trying to stay ahead on the connectivity and then using a breakout cable to get to 2x400. But you're ready then for when you get an 800 gig interface coming along. But of course, one of the benefits of using standard Ethernet switches is that, okay, when we get to say 1.6 terabit network interfaces, your 800 gig switch can then be reprovisioned maybe on the front end for where the inferencing network comes in, or somewhere else. Yeah. So I think the actual reuse will be a lot better on the network. And I think there is a healthy market as well for previous generation GPUs. Yeah. So there's some business cases that says actually, if you can go and buy a bunch of NVIDIA A100s, which are kind of N-2 generation, because of the price you can get them at these days, you know, you can churn out tokens at a pretty effective rate. Yeah.
Fantastic. Thank you very much.